Okay, in this lesson, we're going to look at equations for circles and ellipses. And we're going to start with circles. An ellipse is kind of a flattened out circle or stretched out circle. But first of all, let's define a circle geometrically. And I'm sure you've seen this definition before, but a circle is the set of all points It's the set of all points in a plane that are a fixed distance from a fixed point called the center, that are a fixed distance from a fixed point in the plane. And we call that fixed point the center. Okay, so once again, a circle is the set of all points in a plane that are a fixed distance from a fixed point in the plane, and that fixed point is the center. And so the standard form of a circle with the center HK, hopefully you remember this, and with radius R, is x minus h squared plus y minus k squared equals r squared. You have seen that equation before, and so we're going to work with that some today. Now let's look at an equation that is not in this standard form. This is the standard form of the equation, but you may not always see it in the standard form. For instance, this is the equation of a circle, x squared plus y squared minus 16x plus 14y plus 32. That's the equation of a circle. We want to see if we can find the center and the radius of this circle, and in order to do that, we have to complete the square in x and in y. So I'm going to group together the x's, x squared minus 16x, leave a space, plus y squared plus 14y, and then subtract 32, or move it to the other side. Now, to complete the square, hopefully you remember, I'm going to take half of this term, half of that middle term, in this case it's 8, and I'm going to square it and add it to this side as well. And then we're going to take half of this term and square it, and I have to add it to the other side. I didn't leave myself enough room there. All right, now I can rewrite this in standard form. X minus 8 squared plus y plus 7 squared. Remember, these signs have to match. And I think now you can see why I said 8 squared instead of just putting 64, because it's easier for me to rewrite it as this binomial squared, equals, we'd have 32 plus 49, which is 81. So our center is 8, negative 7, and our radius is 9. And now we have enough information. We could graph that circle. Let me see. Okay, I'm not going to be able to graph something on here that looks extremely circular. But if we have 8, negative 7, 2, 3, 4, 5, 6, 7, 8. It's not going to show up good here. Here's my center, and my radius would be here. This is negative 7, so if I have a radius of 9, I'm going to go up And I would count over 9 here and count down 9, which I'm not going to have enough room, but you could draw a circle. If I was doing this on a piece of paper, I have a circle maker that looks more like an ellipse than a circle, but we'll pretend that's a circle with radius 9. This is 9 all the way, even though it doesn't look right. My circle making skills on the iPad are not good, but we got the center and we got the radius. Okay, let's do another one just to get a little bit more practice completing the square. I want to find the center and the radius, and if I were doing this on a piece of paper, then I would graph a circle. We'll see how we can get that done. Okay, x squared minus 6x. Remember, we group our x's, and we're going to group our y's, plus y squared minus 8y equals negative 16. Right, we take half this term and square it, and I'm going to add it over here. And I'm going to take half this term and square it, and we'll add it over here. So we can get x minus 3 squared plus y minus 4 squared equals 9. So our center is 3, 4. Our radius is 3. So this one I might be able to do a little bit better. Here's my center. And if I have a radius of 3, my circle is going to look something like this. Again, it's not a perfect circle, but that's a little better than the last one. Now we want to look at ellipses. All right, an ellipse is the set of all points in a plane the sum of whose distances from two fixed points, and these are called foci, is constant. The center of an ellipse is the midpoint of the segment between the foci. The center of an ellipse is the midpoint of the segment between the foci. And that could be an important piece of information if you're trying to find an equation and you have the foci, then you can find the center by finding the midpoint. So that's a geometric definition of an ellipse: the set of all points in a plane, the sum of whose distances from two fixed points, called the foci, is constant. The center is the midpoint of the segment between the foci. Now we're going to look at the standard equation of an ellipse with the center at the origin. Today we're just going to look at the origin, and in the next lesson we'll look at a center that's not on the origin. Okay, an ellipse with the center at the origin, or at the point 0, 0, there's two options. You could have the major axis horizontal or the major axis 0. And the form, if the major axis is horizontal, is x squared over a squared plus y squared over b squared equals 1. The vertices are the points negative A0 and A0. The y-intercepts are 0, negative B, and 0, B. And the foci, now remember, the center is at the origin. The foci are negative C0 and C0. And C squared equals A squared minus B squared. If we were going to, this is a rough sketch, remember. See, this is negative A, 0, A0. Here's 0B and 0, negative B. The major axis, or the longer, is horizontal, and that corresponds to A. Okay, so that's a quick sketch of that ellipse. The length of the minor axis is 2B. Okay, so the length of the major axis with the center at 0, 0 is 2A. Okay, so let's look and see what the equation would be if we have the major axis vertical. It's going to look very similar. The major axis is vertical. The equation is going to be x squared over b squared plus y squared over a squared equals 1. Your vertices are going to be 0, negative A and 0A. Your x-intercepts are going to be negative B0 and B0. And your foci, I'll just put an F there, are going to be 0, negative C, and 0C, and again, C squared equals A squared minus B squared. So if we were going to look at that, this is going to be 0A, 0, negative A, B0, negative B0. So here's our ellipse. That's a vertical major axis. So let's look at some examples of how we can find an equation given some information, and then we're also going to look at an equation and find the vertices and the foci and draw the graph. Okay? When you have a test or a quiz, I will give you a sheet that lists this information. So the more you write it down, the more you work with it, the easier it's going to be for you to remember. You've got to be familiar with what everything stands for. Okay? All right. Here I have some vertices and foci, and I want to find the standard form of the equation of this ellipse, and then I want to graph the ellipse. So let's see. I'm going to go ahead and graph a little bit here. If we have negative 5, 0, this tells us that this is going to be 1, 2, 3, 4, 5. This is going to have a horizontal major axis. So it's going to be in the form x squared over a squared plus y squared over b squared equals 1. Okay, so it's often a very good idea for us to kind of sketch things out so we can tell whether we have a horizontal or vertical major axis. All right, because I know that my vertices are negative 5, 0, and 5, 0, and this is centered at the origin, I know that A is 5. And since it gives me my foci, I know that C is 3. And if C squared is equal to A squared minus B squared, then I also know that B squared is A squared minus C squared. And in this case, it's going to be 25 minus 9. So B squared is 16. So now I have everything I need to put this in standard form. X squared over 25 plus y squared over 16 equals 1. This is in standard form. And if I want to graph that, if b squared is 16, then b is 4. So here, and I've got enough information to graph my ellipse. All right, I know that's not a beautiful ellipse, but you get the idea. All right, the length of the minor axis is 8, it's 2b. If you need to know the length of the minor axis, because sometimes you might be given the length of the minor axis and asked to find the equation. Okay, let's do another one that's kind of given in this form. Okay, I want to find the equation of the ellipse that satisfies this information. All right, so I need to determine first, and I usually like to graph it out so I don't get confused. If the vertices are 0, negative 8, and 0, 8, I have a major axis is vertical, so it's going to be in the form x squared over b squared plus y squared over a squared equals 1. Well, if 2b is 10, then b is 5, so b squared is 25. And a squared is, a is 8, so a squared is 64. And that is the equation of the ellipse that fits this information. If we needed to find the foci, c squared is 64 minus 25, and 5 from 14 is 9. 2 from 5 is 3, so c is the square root of 39, which would be a little bit more than 6 if we were going to draw that. If we were going to graph our ellipse here, if b is 5, here's the minor axis, 1, 2, 3, 4, 5, 6. Foci somewhere in here, we'll just a little bit more than 6. But your ellipse would look something like this. Right, has a vertical major axis. Okay, I want to find put this in standard form. This is an ellipse. I want to find the vertices and the foci and draw the graph. Now notice in standard form, it's always equal to 1. So I'm going to divide everything by 36. Because it has to be equal to 1. So this becomes x squared over 4 plus y squared over 9 equals 1. We have a vertical major axis. We know that A is 3, B is 2, and C squared is equal to 9 minus 4. So C is equal to the square root of 5. So our vertices are here, and that is the point 0, negative 3, and 0, 3. Our foci are 0, negative square root of 5, and 0, square root of 5, which just is a little bit over 2. And then B is 2, so that helps me in graphing. And here is our ellipse. So that's not too bad. All right, let's look at one where we need to complete the square. Never mind, with the center at the origin, you're not going to have to complete the square. We'll save that for the next lesson. All right, your assignment. This is assignment number 11. All right, I want you to do on page 734, 1 through 6. Okay, on 1 through 6, give me the center and the radius, as well as matching it with the correct graph. Tell me what is the center, tell me what is the radius, and match with the correct graph. You're going to get a point for each of those. So be sure that you work that out, the center, the radius, and which graph it matches. And then I want you to do 12, 24 to 32 even. Okay. And that is your assignment.